We're trying to determine the enthalpy of the reaction of this particular equation here. And so with these 4 different equations, we're going to try to combine them together to create this net equation. So we need to be very careful of what's on the left side, what's on the right side. We'll start with this m right here. So we know that this equation has the m already on the left side. We're going to leave it as it is. And this one, we don't really know any information about HCl from this equation, so we're not even going to touch that one yet. Over here, let's look. We know Cl2 needs to be on the left side. We're going to leave that one the way it is. And over here, Cl3 solid needs to be on the right side. We see the solid on the left side here, so we actually have to switch this equation around here. We're just going to make a quick adjustment here. We're going to change this one to the AQ version, this one to the solid version, and because of that, we're actually going to be able to change that from a negative to a positive sign, and now we have the correct enthalpy for that equation. And so the M is going to be on the right side of here, MCl3. Now from here, we need to basically check our work because we don't know any information about these HCl's over here. So let's try to add this up and see what we get so far. Before we add them up, let's make sure that we have the proper coefficients here. So the 2's are already proper on the m's. We kind of need 3 Cl2. So let's multiply this equation by 3 and also the enthalpy by 3. And then for the MCl3's, we kind of have to get 2 of those. So let's multiply that one by 2, multiply that one by 2. Now that we have the right coefficients, let's go ahead and just try to add up these 3 and see what we're missing. See what is this equation going to do for us. So let's go ahead and do 2ms plus 6HCl. We're going to skip this one. We're going to go straight to this one. We need 3 H2s. And then we need 3 Cl2s. And then this is just the left side here. So we're just going to go 2 MCl3AQ. So for the right side, let's go ahead and try to add those up. We're going to start with 2 MCl3AQ plus the 3H2 gas. We're going to skip this one. We're going to go straight to here, but we need 6 HCl in gas form. And then we need to go to 2 MCl3 solids. Now we can start to see what might cancel from these things because this is supposed to be left and right side, right? Well, we have the gases of H2 canceling. We have the AQ version of these canceling. So we're close to getting our net equation. We have this, and then we have this on the left side, and then we have this on the right side. So the only things that we're missing is this AQ and this gas over here. Let's make sure that on the right side we have the AQ, and on the left side we have the gas, so that way they can actually cancel. So if we multiply this by 6 and add this to the left side, the gas version, 6HCl gas, then it will cancel from that side. And if we add the AQ version on this side, 6HCl AQ, then it will cancel from that side. And so now we've been able to get that. And we have our final net equation. So at this point, all we have to do is just add up these energies and see what happens over here. Before we do that, let's make sure to multiply this by 6 because we kind of forgot about that. But now we can add these up. So we're going to go negative 936, and then we're going to go and add 6 times negative 74.8, and then we're going to add 3 times negative 1845, and then we're going to add 2 times the positive 371, and it turns out that the total for this HRXN is negative 6177.8 kilojoules. Pretty cool.